Hello dear students, I am Samir Velankar and I welcome all of you to this video which discusses linear queue again, but this time using linked list. Previously we saw how to construct linear queue using array. There was an array of fixed size and there were two counters, front and rear. Front and rear were purely integer variables. Now in this video we will see how to construct a linear queue using linked list. Now, the diagram which I have drawn here is a singly linked list, isn't it? Because every node has only one pointer, that is next, and points to next node. Now, the diagram here, this diagram is nothing but linear queue. Watch, linear queue here is having three nodes storing 10, 20, 30, and 10 was inserted first. So, there is a pointer called front. Front pointer is pointing to 10 and 30 was inserted last. So rear pointer is pointing at 30. So linear queue is nothing but, it is nothing but a singly linked list. Just create a singly linked list, but using two header pointers. In a singly linked list, we keep only a pointer at the first node. But when you are creating a linear queue, you keep two pointers, one at the first node and one at the last node. Now, advantage of this, keeping the pointer at the last node is, imagine insert operation. You know there are two operations on queue, isn't it? Insert and delete. These are the two operations on any queue. Imagine an insert operation in this queue, the above queue. Suppose you want to insert 40. Then the summary of the insert would be, you create a new node using malloc, and let's say temp pointer points to this node. So typical statement will be temp is equal to malloc size of node, isn't it? Now using temp arrow data notation, you can store data here and temp arrow next will be null. So this new node, is now the latest node which is joining the queue. So you know that the latest node or the node which is joining at the moment should become the last node. So what is the assignment that we do is rear arrow next becomes equal to temp. This is the assignment we make. Check that rear arrow, this is where I am pointing. Rear arrow next, this next should point wherever temp is pointing, and temp is anywhere pointing at node 40. So rear arrow next points to 40. That means the next of 30 is no more null. Next of 30 now points to 40. One more change we are going to do after the line, after having assigned rear arrow next equal to temp, we are going to make rear equal to temp. That means rear pointer, which was pointing at 30, should now point to the node where 40 points, where temp points. Temp is pointing to 40, so rear pointer is becoming equal to temp. And that's it. That's insertion. Now what you find out is front is still pointing to 10, but rear is pointing to 40. So the elements of the queue are 10, 20, 30, 40. Just in case we want to repeat this one more time, let's say you are inserting a new node, say 50. So 50 is allocated using a function like malloc and temp points to this new node. Yes, then temp arrow data is filled with some value. Temp arrow next is made null. Now the next line is rear arrow next. So watch out for rear arrow next. This next we are talking about 40 is next should become equal to temp. So 40 is next was null, but now 40 is next points to 50. And one more change we are going to do is we will ask rear not to point to 40 anymore, but rear should point to the latest node, that is last node, and last node is where temp is pointing. So rear should become equal to temp. So easy, isn't it? You just create a linear linked list. Linked list, a singly linked list will create a linear queue. In fact, I won't be wrong if I tell you that we have already seen full length C program, and that program which we created for a singly linked list just a few videos back, the singly linked list program was a program for linear queue, and that program was actually seen in three parts. We created three videos for learning that program, I think so, yes. Okay, so I hope you have understood a summary of insert operation. Now what about delete? Suppose you call delete on this queue, then you know that 10 should be deleted because 10 is the frontmost. Now watch out that if we are deleting 10 from this queue, then we should ask front not to point to 10, but front should point to 20, isn't it? Because 20 will become the frontmost. So if the delete function is called, I'll just make some place on the slate. If delete function is called, then front should become equal to front arrow next. That's the summary of delete function. Tell me if front becomes front arrow next. Just check this. Front becomes, check the pointer, front becomes front arrow next, but front arrow next is pointing to 20, isn't it? So front will point wherever front arrow next is pointing. That means front will discontinue to point to 10, but front will point to the next node, that is 20. And you can see that 10 is as good as deleted, correct or not? Because now the queue starts at 20. But additionally, you can free the node 10 by calling some function, library function like free. You can release this memory. This facility was not there in the linear queue using array. You cannot clean up that element of the array, isn't it? But here you can actually return the memory back to operating system. Also, there was a problem in linear queue using array. When you used array, there was an overflow problem. The array might be full and then there is no place in the array, so overflow was announced. But here there is no such problem. Just imagine you want to insert 60 in this queue. So what? You call malloc and ask operating system for more memory and more memory. Of course, there is a limit that when memory will become full, then malloc won't be able to allocate space, but that's very far from reality. Memory never gets full. I mean, at least I have not seen. Maybe you have seen if you are using a lot of data in your while creating your program. Anyway, so the advantage of creating linear queue using linked list is we don't have overflow problem here. That's what plainly we can say, because the overflow will occur only when memory will be full. But in linear queue using array, the overflow problem can occur because the array has fixed size and sometime later the array will become full. One more advantage of using linear queue using linked list is that you can actually release the memory by calling some function like free, and you can return the memory back to operating system when you are calling delete, isn't it? But that's not possible when you use array. You may delete a value in the array, but that element will be still there in the array. Okay. Let's summarize the delete function again. Suppose you call delete again on this queue 20, 30, 40, 50. Then 20 should be deleted, isn't it? So what will you do? You will ask front not to point to 20, but front should point wherever front arrow next points. That's it. So front will point to 30, isn't it? And 20 will be released. This node 20 will be returned to operating system by calling free. Okay. So for some time, now you imagine that we delete 30, we delete 40, and only 50 remains. Only 50 remains. So front is pointing to 50, agreed? And rear is also pointing to 50. Fine. Yes, it should be because there is only one person in the queue. Isn't it so? Now what? Now if you try to delete 50, then front will become front arrow next. You know the summary of delete, isn't it? What if you call delete? If you call delete, then front will point to the next of front, but next of front is null. You watch, isn't it? So there is no next person. So funny it is, so funny to tell front that, okay, I am deleting 50, front you point to the next node, but hello, next node is not there, isn't it? So we will have a condition as if front is same as rear, if front is same as rear while deleting, then make both front and rear equal to null, equal to null. Now 50 is getting deleted where front and rear both are pointing to 50. So if 50 gets deleted, then front and rear both pointers will abruptly become null, and they should, because the queue has become empty after deleting 50. Nothing is remaining, isn't it? So both front and rear, this pointer front and rear will become -1. Null. Otherwise, you say front should become front arrow next. Yes. Then there is next node which can be appointed as the frontmost. I guess you have followed what is exactly linear queue using linked list. And I repeat, the program that we saw using singly linked list few videos back, it was seen in 3 parts, is in fact the program on linear queue using linked list. Now let us get to circular queue using linked list. We created circular queue using array just in the previous video. Now what is circular queue using linked list? Circular queue using linked list is nothing but a circular queue, a circular linked list, isn't it? You have a linked list which stores 10, 20, 30, and each node has next pointer which points to next node. And just imagine that the next pointer of this last node, imagine 30 is the last node, points back to 10. We again have a front pointer which points to the frontmost node added and rear pointer which points to the last node added. Now, in case you want to know how circular queue is done using C program, hello, we have written a program or we have studied a program on circular linked list just a few videos back. Circular linked list, the program learned was a program on circular queue. Okay, let's see. Suppose we want to insert one node here. So what do? You create a node using malloc, let temp point to that node, let temp arrow data be 40. Okay, now what's the next change? You see this, that 40 is next. Now 40 is the last node, isn't it? 40 is next should point back to 10. But 30 is next is pointing to 10. That's wrong now, isn't it? So what we do is we ask next of 30 to point to the latest node. We ask next of 30 not to point where it is pointing, but next of 30 should point where temp is pointing because temp is pointing to 40. So that is done by writing a statement rear arrow next equal to temp. So rear arrow next, watch this. This is where rear is pointing, arrow next, this next should point where temp is pointing. Isn't it so? Now one more change we will do. We will say rear should be equal to temp. That means rear won't point to 30 anymore, but rear will now point to the latest node, that is temp that we have added. And now comes the fun part. We will say temp arrow next, or rather, why don't we say rear arrow next? That would be better, isn't it? Because rear is anyway pointing to 40 now. We will say rear arrow next should be equal to first. So rear arrow next, 40 is next, will point where first is pointing. So simple, isn't it? These 3 lines summarizes the insert function on a circular queue. Just create a new node, ask temp to point there, store the data, and then wherever rear was pointing earlier, rear was pointing to 30, rear arrow next should point where temp is pointing, isn't it? And then ask rear not to point to 30, but to point to temp. So rear will now get repositioned. Rear will point to the latest node and finally ask the last node's next, that is rear arrow next, I'm so sorry, rear arrow next to point back to first. That's insertion, isn't it? And we saw this in detail in the video labeled circular linked list. There was a video labeled circular linked list where I have explained a C program to create a circular queue. Okay, what about delete function on a circular queue? Delete means frontmost element should get deleted, isn't it? 10 should get deleted. But if 10 gets deleted, then front should be asked to point wherever front arrow next is pointing. That means 20 should become frontmost, isn't it? So front should become front arrow next is the statement. And one more change has to be done. Yes, everybody knows that. One more change is now rear arrow next, that is 40 is next, last nodes next cannot point to 10, but last nodes next should point to the new front, correct or not? That is 20. These changes will have to be done to delete 10. I hope you are understanding it, isn't it? So, what are the statements to delete? You will say front becomes front arrow next. So, front will move to the next node. And you will say rear arrow next, that is last node's next, should become equal to new front. It should point to the new front node, isn't it? So, just execute these two lines again on the queue. 20 should get deleted. First, we say front should point where front arrow next is pointing. So front won't point to 20, but now front will point to 30, correct? And then one more line, you watch, the second line was rear arrow next, that is 40 is next, should point to the new front. That means it will point to 30 and it will discontinue, obviously, to point to 20. Rear arrow next is now pointing to 30, and so the 20, the node 20 is as good as deleted. So that's the way how we can build a circular queue using linked list, isn't it so? And linear queue using linked list. I hope you have understood and you can relate this to a C program. Thank you very much.